Yesterday, we were going over questions in section 9.4 improper integrals. There was one more residual one left over. However, I had you guys writing down your review to start off class, and I was reminding you that today is mostly a work day. However, I do desire everyone's attention right now, so let's go ahead and shut the mouth. As I share a few details about the test so that everyone can focus, that would be helpful, that would be productive, I do believe. Tomorrow's test, I think I mentioned yesterday, but I'll remind today. It's not as long as some of the other ones that we've done. Does that mean that's going to take all of you the entire time period? Because, oh man, these all must be long. No, but some of you take longer than others on these ones in particular, especially because some of the integrals, where did integrals show up in the chapter 9? 9.4 improper integrals. Some of the integrals will take some of you longer, especially if there's integration by parts, which there is. Especially if there's trig sub, which there is not. But some of the integration will take some of you guys longer. That was something for me to consider. And some of the limits. Wait a minute, where does limits show up? Everywhere. L'Hopital specifically, but also it's used in comparison, and also it is used somewhat in sequences. Because we were taking some limits to infinity of those also and trying to test their convergence. Oh, did we have some new things show up this chapter? Yeah, but we'll cover those in a second to make sure you guys have all the terms right or down and that you have all the random extra things since we're not having an endeavor quiz. You know specifically what you should probably peek at for tomorrow. But L'Hopitals will take some of you longer as well. So along those lines, especially L'Hopitals where you have an F to a G. An F to a G. Like those ones you need to use ln on both sides. Remember those ones? An F to a G. You have to take ln on both sides. One of those ones. Some of these might take you longer. So thus I've tried to accommodate. So my accommodation is there are only 16 questions on the test instead of 20, because most of them have had 20 up until this point. Only 16 questions on the test. We're not splitting this up into multiple days like tomorrow and tomorrow alone. But that does mean some of you will finish early, so make sure you bring something additional to work on. Maybe it's just reading, what book are you guys on now? Hamlet. Maybe it's just reading Hamlet to be. Not there? Yeah. Toil. No, that's Macbeth. Isn't Macbeth the witches? Yeah, that's Macbeth. We read that last time. Wrong one. No. This semester you get to contemplate suicide with Andrew.
It's definitely about suicide.
I think that there very well could be a deeper meaning to it, but on the surface level, right? But that's all our
There's actually part
creative religions.
From why he made the why he committed suicide.
It's at least partial. If nothing else, it's a great time to discuss, but okay. But there's no other mind to suffer the slings and arrows about previous fortunes or by opposing them. God, sleep to sleep, perchance to dream on. There's the love, what's going to come after. Anyway, good stuff. I had to memorize this a little bit in high school, but obviously I don't remember the whole thing. And it wasn't like all of Hamlet. And I'm pretty sure I pieced a few pieces together because I was reading it the other day for some random reason. It was somewhere, and I was like, oh, I think I messed that part up. Anyway, okay, so the test is going to go in order as it always does, 9-1 all the way to 9-4. So improper integrals are at the end. Comparison growth is right before that. L'Hopital is right before that. Ooh, la hospitals, but you guys know we say L'Hopital. And then sequences and series sequences are right before that. It could be helpful. It could be helpful as far as thinking of memorizing, having ready stuff that's not like right off the top of your head, to look at the special formulas for the nth term of arithmetic and geometric sequences. We are in BC, so I'm assuming a lot of us can kind of just grasp patterns and work with it, and yet there are some nth term, there are some nth term formulas that might be helpful if you wanted to memorize them. Remember the whole like times r. You can do a1r to the n minus 1 for a geometric, or plus d. You can have a sub 1 plus n minus 1 times d. I'm not saying you have to, I'm not saying you have to. I'm just saying you could. And it might make it easier. So some of those arithmetic and geometric nth term formulas. Some of those nth term formulas, they might be helpful. What is n allowed to be in a sequence? N is like x, but what's different with n that's not with x as far as its domain? It can be 0, can be 1. Is a variable. Can it be 0.1 or 0.5 or 0.7 or 0.9? No, what does n move by? Integers, whole numbers, so n is just 0, 1, 2, 3, 4. So if they say something like find the first 5, don't we just plug in 1, 2, 3, 4, 5, right? Does that make sense? It's called discrete functions, that's not the test. If it's asking for whether a sequence converges or diverges, do we have a convergence of a sequence?
Not serious.
Card and debit card? Yes. But what's the long story short? Because it's just a basic application of limits. When will a sequence converge? When the limit equals a constant, 0 or a number, right? Is 0 a number? Or is it the absence of numbers? We're not going into that debate. So 0 or a number, 1, 2, 3, 4, doesn't matter, any constant. If it stabilizes to a single value, it converges, right? If it doesn't stabilize, what could that look like? What could the limit equal such that it would be divergent? Infinity or negative infinity or oscillating not towards a single value. Question, what are some common functions that oscillate but not in a smaller, converging way? Sine or cosine? Are they stuck? Yeah, between 1 and -1, but are they ever converging? No, they're forever switching around, right? Okay, so convergence, divergence, just a quick reminder, that will be some terminology, some concepts that you guys have to have down. What do we worry about or not worry about when we have an alternator? Not the part of a car, but kind of similar if you know about currents and circuitry. Alternator. What's an alternator in an equation or function? -1 to a power, right? What happens when you have -1 to a power? What does it do to numbers? Flips. Positive, negative, positive, negative, positive, negative. Joe, this is in line with, I don't remember, I think it was an example in class that you answered. When will alternators still be convergent, and when will alternators be divergent?
Like sine x going to infinity.
Will be which one?
Will be convergent.
Because sine does go between positive and negative, however the over x is stronger, and so that whole thing is getting smaller and smaller and smaller. So even though it's bouncing in a way that it's stabilizing because it's going to 0 as you go to infinity. Right? The value of the function is going to 0, I should have specified, as x is going, or n in this case, is going to infinity. But when will an alternator, positive, negative, be divergent? What if you have anything besides 0 and you have an alternator? What if it's 5? What if it's 7? What if it's 10? And you have a negative, positive, negative, positive. Is that good or is that bad? I can't just give you the test question. I'm really trying to generalize. If you have positive, negative, and the limit is a constant, but it's not 0, is that good or is that bad? It's oscillating, but if it's not going to 0, is it going to be stabilizing? No, it's going to be going, and then it's going to be going, and then it's going to be going, and it's going to be going. If it's anything but 0, that alternator is going to. Okay, that was painful. Multitals. Okay, multitals. So we have lots of different indeterminates. But what are the two that we need before we can apply actual L'Hopital's rules? 0 over 0, or infinity over infinity, or if we were answering it in an FRQ fashion, thank goodness it's multiple choice. In an FRQ fashion, we'd have to write limit of the top is 0 and limit of the bottom. Limit of the top is infinity and limit of the bottom is infinity. Those are the two that we need. So if we have a different form, what do we have to do? Somehow convert, right? Somehow change, somehow transform. A multiplication becomes a division, or F to a G, we put in an ln and try to play with it that way. But if we have an f over a g where the limit at the top is 0, limit at the bottom is 0, or the top is infinity, limit at the bottom is infinity, yes, we're allowed to apply L'Hopital's however many times we need it. And if I say use L'Hopital's, I want to see L'Hopital's. When do we have to stop using L'Hopital's? When it's no longer indeterminate. Good. Should you maybe look at some of those indeterminate forms just to make sure you know which ones work and which ones don't? Like which ones you should be going FG and or F over G and which ones you shouldn't? Just a heads up. Okay. Comparison. What section is that? 9.3. Okay. We have faster versus slower. Going faster versus going slower. And we have more efficient versus less efficient. Those are the two comparisons, right? Which ones were the ones that we talked to first, more fundamental? The faster, slower, or the efficient, less efficient? Faster, slower. That was like the crux of the whole thing. Comparison of growth rates. So faster or slower. If I take a limit of somebody over somebody and I get 0, what's true about the numerator versus the denominator? If I get 0, who's faster? Bottom, because bottom wins, right? Faster, slower, it's just about who wins. So 0, the bottom wins. If it's infinity, infinite, which one wins? The top. What happens if I get any constant, though, besides 0? Same rate. That's a little complicated. Same rate. Okay, but what if I'm asking for efficiency? Who is more efficient, or what process, program, whatever? Which function is more efficient? The faster one, getting bigger faster, or the slower one? Slower is the more efficient, not because it's slow, but because it's lower, and the fewer the steps, the more efficient the model. Does that kind of make sense? Something for us to look at? Okay, somewhere in here, did we talk about special converging sequences? I don't think we did today. It might be good to look at that in Endeavor card, just in case something funny shows up. Otherwise, you guys have some improper integrals. When do we need to take a limit of a bound? When it's either infinity or negative infinity or discontinuous. When do we need to split up an integral? If there's a discontinuity in between, or if we have two bounds that are both issues, we have to split up. I had Kyrie, you asked me, Lorenzo, you asked me, no, Gavin asked me, what do we split it up at? If I need to split up a negative infinity and an infinity, or a discontinuity and an infinity, if I need to split it up to be able to take two separate limits, easiest one. Just pick a number. Pick something easy in between where it'd be easy to plug in and solve. And then otherwise, you have to be careful as far as solving your integrals and then plugging in your B's and your A's and then properly approaching. Some of you, just a couple of you. Do you enjoy when you have to approach ever in an integral something from one side? No. But how do you ultimately do that? Yeah, actually solve the integral first. Plug it in is what you try to do. Make sure your domain is existent. Like if I plug in 2.1 and it doesn't exist, I'm in some trouble, but hopefully it exists. It should exist. Don't plug in 2.1 though. Just plug in 2 and see if it works. If it works, you're probably okay, unless it's a weird piecewise function, and even then you're only coming from this side. Okay, a piecewise function, you gotta pick the right portion, the right piece. But you don't have piecewise functions on the test. I don't think. Not even any absolute value. I don't think. Just plug it in. Just plug it in. The AP, of course, will throw weird things at you, and so if you're coming from above or below, you have to be careful. But for our purposes, just plug it in. Alright guys, I've walked through pretty much all of the 16 problems, not specifically as far as telling you exactly the types of functions. I told you the tricky ones. There's some exponentials, there's some logarithms, there's some trig. There's an f to a g that I tried to hint at. Ooh, there is a a b to the u. There's a b to the u. But anyway, a to the u, b to the u, like a 3 to the x or a 5 to the x. Okay, with that, I have the review in front of me. We're going to go peek at number 39 real fast that some of you I know don't need, but that was that problem that I ran out of time on yesterday, and I finished it, and it was on the video, but I didn't really explain it super well. I think I pretty much did it quietly. Oh. Is that 39? No, that was my Gabriel's horn. Oh, here's 39. Sorry. 27. I did him. Did I not save him? Oh, this is sad. Oh, there he is. Was it not 39, AJ?
Yeah, well.
Okay. Yeah, 39. Sorry, I just put him before 53 because that was the natural order. 39, you wanted to make your u your tangent of inverse. Sorry, tangent inverse of v. Then I had to do my u sub, which matched up perfectly, which was awesome because this was really just an integral of 16u. All of this is just an integral of 16u. So I ignored the 16. I had him out here. I just integrated this guy, which is u du ultimately when you do a u sub if you need to. And what's the integral of a u? 1/2 u squared. So I brought that in, boop, and then I put in my b and I put in my 0. What's weird about tangent inverse? Maybe not for tomorrow, but for the AP. What happens as t goes to infinity? Infinity! He has a vertical asymptote that was flipped with the whole inverse action. How high can tangent inverse go? Pi/2. How low can tangent inverse go? If I was ever going to negative infinity, I'd have that as a limit. So actually, even though I'm going to infinity, he will never pass. So I go ahead and let my limiting value be pi/2. Tangent of 0, sorry, tangent inverse of 0. Tangent hits at 0, 0, so plugging in 0 is 0. Tangent of 0 is 0. I should say tangent is 0 at 0. Either way. That was just 0. I shouldn't even use the arrow, sorry. I should have just said equals 0. It wasn't approaching, it was equaling. And then, plug in. Now, I'm going to go ahead and go over to the review. Some of you have started it and maybe got stuck, or some of you maybe just ran out of time. But I am ready. I am available. If you want to ask me and if you just want to work, go for it. I think I've given you enough hints and tricks and whatnot. At least things to keep your eyes open for. But is there any place that you guys got stuck you want to talk about? There was a 70-something. There was a 50. Oh, 50. Let's start at 50. Let's go to 70. If you guys haven't gotten there yet, if you want to pay attention. Oh, 17. Oh, let's start there. Let's start there. You can go to the back of your homework spiral if you want. Or you can just pay attention and know that it's on the video if you need it.
Can we also do 11?
Oh, yeah. Can I go back there? I'm going to go back. Sorry, Iris. 11?
Yeah.
Can I just move this without me moving? That's okay. Hold on. Oh, I can't get this little box gone. This is so annoying. Oh, but I don't think anyone asked. I think we asked on 11 and 17. Okay, going to 0, I see 0 over 0. Right? Top approaching 0, bottom approaching 0. That's proper context. So locales. Nice thing is, multiple choice, don't have to stress too much. Second D first. Plus first D second. All over. No positive sign of X. Brother is sine of 0 is 0. But if I go one more time, that's cosine, which is going to be 1. So one more iteration of locales and I'm good. I just need to do a little bit of work here. So I have my cosine, and then I have my second D first. And then I have my first D second, which will be a negative. Plugging in 0, that's 1, that's 1, that's 0, that's 1. So I see a final answer 2. Does that seem to match up? You're double checking though. 17, right? Okay. 17. Oh. This is why I had you guys, just like this type of problem, double check your indeterminate forms, because this one would be, wait a minute, 1 over 0. Oh. Okay, here's just a random pre-cal fact. Some of us forget. What is ln of 1? 0, because that's where ln crosses the axis, if you want to think about it that way. Or you could also think about y equals ln of 1. It'd be e to the, how can I raise e to a power, sorry, my bad. How can I raise e to a power to get 1? Has to be the 0 with power. a couple different ways. But either way, why am I saying that? Because if I go plugging in, I get 1 over 0 minus 1 over. But isn't that just 0? Isn't technically this? If I was to plug in 1 a little bit below, a little bit above, I think I have some infinity action going on. I think positive, negative infinity. And this one I have going to 1, positive and negative. Okay. So you guys, right now I'm kind of seeing infinity minus infinity, which is indeterminate. In which case, I would say common denominators. And let's double check that it truly is indeterminate, because if you get common denominators in f over a g, I should see one of those forms. Oh, sorry, 1. Thank you. I would get 0 minus 0. Oh, that's a 0. And then I would get 0. Okay, it is indeterminate. Now I know for sure 0 over 0. In which case, L'Hopital. So I'm going to play around with, okay, that's not bad. And then this one, second d first, minus first d second. I'll double check it's still L'Hopital. I do see a 0. I should show. And I do see a 0. But I also see that I maybe could condense some stuff, meaning I think I might want to multiply top and bottom by x, because I don't like these fractions. So you are allowed to play with this and change it up and see if it's possible. So like changing this one, I would get 1 minus x. And changing this one, I would get, well, those reduce, and it has to go over here. X minus 1. Is that the same thing? No. I still have 0 over 0. But now my L'Hopital is at least a lot easier, because I just have negative 1 over 1 minus. I don't have 0 over 0 anymore, so I'm going to have a solution. So now it's second d first minus first d second. Got it. So I can go ahead and plug and chug. I'll get negative 1 over 1 minus 0 plus 1. I think I get negative 1. Sorry, I did it kind of fast, so I keep on practicing what I think. Does that sound good? Huh? Okay. And then the last one, Lorenzo, at least for right now, from ones I've heard, is 50? Yeah. Ooh, the comparison test. Well, the struggle is the comparison test is kind of hinting that it might not be possible to solve otherwise, right? The comparison test is pointing to the homework in section 9.4, where I think the idea was, can you use, in some senses, the squeeze theorem to figure out what it is? By comparing it to other functions. Oh, there is a comparison test that's coming that we haven't learned yet that does have to do with infinite series. But we haven't learned that yet. In the section 9.4 comparison test, if I remember right from section 9.4, I think they're just trying to get us to squeeze it by comparing to 2 integrals that would be on either side. Which in this one, I mean, you could think about e to the negative t and then t to the negative 1/2. I'm just thinking integration by parts, because on the test you need to think of that too. But in this one, I could keep deriving and integrating this all day. It stays the same. I can keep deriving and integrating this all day. It's a fractional exponent. It will never go away. And it will never repeat, so I can't use loopy either. Because this will keep changing whether I'm deriving or integrating. So right now, integration by parts is impossible. U sub is impossible. It doesn't match. Trig sub, I don't have an a squared plus or minus u squared or b squared, so that doesn't work. So instead, it might be more helpful to think about what this is in between. So I want to consider who this guy actually is. And then look at my pieces. So I see like a 1 over e to the t. and I see a 1 over square root of t, and I'm trying to think of which one is predominant to the place where it would encapsulate, it would bound, it would hold in the other, like this entire expression, because ultimately I'm trying to put 1 to infinity of e to the negative t. I'm trying to put it in between two equivalent integrals where it's always greater than, always less than. I could even say or equal to, I suppose. And if these two match as far as the integrals, that one will be squeezed in between as far as the area. Does that kind of make sense?
What was the question?
The presence of e to the t makes this denominator stronger. And the presence of square root of t makes that denominator stronger. If I was to go below, I'm still going to be using my 1 to infinity. One over root t. From 1 to infinity, something to consider is that this won't change nature. It will always be growing. Remember, if it was like negative infinity to infinity, it behaves differently with negative and positive numbers. So this is always stronger. The bigger the denominator, right? The bigger the denominator, the smaller the number. Exactly. So the presence of e to the t would cause this to be a greater value, right? And since this is always positive, I could also do a negative, which would encapsulate as well. Since he's always positive, he would be greater than. Now, I could cheat just a little bit because technically both of these are that special P series, like without doing all the work, I already know what's going to happen. It's going to diverge. No, I know. Sorry. If this one diverges, I don't know how it diverges. So I haven't necessarily, because remember, divergence can happen many different ways, so I haven't actually squeezed it into an answer. So the divergence, even though it was true as far as less than or equal to, I actually don't know how to compare these two and whether kind of like infinity minus infinity, I don't know if it's the same. So since it's not necessarily the same, it can't be squeezed. So okay, that was a good comparison, it just basically failed. So let's do another comparison. What if I was to use instead 1 over e to the t? Does it also squeeze in? Double check, because if it doesn't, it's a bad comparison, so it's a faulty one and won't prove anything. Okay. Always positive values, negative values. Okay, that would squeeze in. This one over here, the presence of square root of t, right, will increase the denominator, keep it lower. I think it's also a true comparison, right? Now, if I was to integrate this one, I can't use the P series, so I actually have to integrate. But e to the negative t, pretty basic as far as integration. So I have my negative 1 over e to the t. If I'm just doing it quickly, it's an antiderivative. From 1 to b, limit as b goes to infinity. And similarly, this one would be a positive 1 over e to the t from 1 to b, limit as b goes to infinity. This one would end up equaling, plugging in b, okay, obviously bottom wins, I'd have 0, right? And then minus and negative would be plus, and then plugging in 1 is from 1, right? Not 0. And over here, same thing. I would have 0 minus stink. Oh, it's just asking whether it converges or diverges. It's not asking you what it converges or diverges to. Oh, they B. This one, if it's in between two constants, it has to diverge, but as to what it converges to. Stinkity. Double check my integral though, that was correct, yeah? E to du and then negative. Plugging in B. You said it converges to 1? I almost have it. It's right there. That would be a better conversion. Well, because it's not the same right now, so that's kind of the hard part. An average, I don't think it necessarily, just because it's squeezed, doesn't necessarily mean it converges to the average, right? Because there is no proof of what it squeezes to. I'm trying to see if I could change this comparison to make it not 0. I want this to equal 1 over e also. That way it, because 1 over e is e to the negative 1. You know what I mean? E to the negative t is e when I have that. It's not truly squeezed unless they both match. What if I was to do 1 to infinity? Hold on, I'm just brainstorming. T minus 1. No, less than, no. Greater than means smaller denominator. Greater than means smaller denominator. Smaller denominator. Oh, plus 1. Here's what I'm looking at. I'm looking at e to the t times root t versus e to the t times e. Square root of 1 is 1. That's 2 point. The square root of 2. Square root of 3. Square root of 4. Square root of 5. Stink. This is smaller, but if I did the t minus 1, that'd be over e. Oh, I don't know if anyone else has a question. Everyone else is just working, so I'm just playing with you. Does anybody have a question I'm ignoring? Sorry. I'm just playing with the runs over here. You guys are good? You sure? Who I'm playing with? My denominator has to be smaller here. It has to be bigger here. So I have to have something that's always bigger than t. How about that would work, right? Because I have e to the t times e to the t. E to the t is always bigger than root t. So therefore, and starting at 1, it's already higher. Starting at 0, I have some issues. But no, even then. Okay, so then the integral would be right? Which plugging in b, that's easy. That or negative, right?
Yeah.
That'd be 0 minus a negative. That'd be 1. Still true, it's just not getting us to a single limiting value like this one's wanting. And if we do 3t, 4t, 5t, we're going to have the same issue.
Yeah.
If I just throw in t, it's going to be impossible to solve. like I'm comparing separately because I'm saying okay because I can't do it together, so I'm comparing and saying okay always higher, trying to find always lower to make it match.
Original function is basically equal to the limit as 1 to infinity of 1 over e root t. It's like we're going to infinity, can we just like neglect it?
Because remember 1 over x diverges, whereas 1 over x squared converges. Things with very similar behaviors can have very different answers. Does that make sense? I see what you're saying. Joe, can you think of another comparison that would match up at 1 over e? The t minus 1, t plus 1 idea works. I don't think it's always higher or less than. T minus 1, 1 over e is not always greater than. I need a variable somehow to offset that one. Let me check out what they do. If they show work. The convergence we've definitely shown, we just haven't shown what convergence. What number? 55?
Yeah.
Oh, sorry. You're B, not me. P.S. There is no comparison test on the actual test. In case some of you are stressing out. The comparison test, no. The faster, slower, efficient, less efficient, all that could be, but this comparison test is actually getting us ready for what's to come.
Is comparison test on the AP?
Not for squeeze theorem of integrals. Comparison test for sequences of the series. Yeah. They just use 0 as their lower limit, which works just as well as all of ours. And they use 1 over e to the t, which is what we did too.
How can they do that?
Oh. You might have read the answer wrong. They're not saying, they're saying the upper limit converges to 1 over e, which means this one is convergent. It's not saying it converges to 1 over e. Oh, good. I was like, I don't think we can find it. Okay, so the deduction was wrong. It was showing the work of this converging to that, which, since it's bounded, I mean, all of these bounded it. We could also do this. Yeah, it means it will be. Yeah, go ahead, kids.
Thank you.
It means it's convergent. That's our final answer. So not that one. That was just that one. No, it's okay. So the 1 over e was just the statement of the upper bound, and then with the lower bound, we know it's a constant. Whew. Should have looked at that earlier. I was trying to be all independent. Yeah. Anyway, anybody else get stuck on something? Sorry, we were just having fun. Good fun, because that's kind of the same brain we need to apply to some of the stuff coming, but we definitely don't all be in that mode right now. Okay, so comparison test not on the test. Not on the test. We're not ready for that as a whole. And the rest, you guys still like 5 minutes? I'll be quiet. I'll get out of here. Just keep working. If you guys want to talk, if you want to collaborate. If you want to ask Lorenzo what was on the test, just kidding. What's on the test, Lorenzo? One page, front, back, all multiple choice. He said something about like faster, slower, but I mean, I believe that too. He was like, oh yeah, I mean faster, slower. Oh, that's right. He had 20 minutes left, so he was able to go fast. Hence why I'm saying some of you will probably wouldn't surely. But others of you, you're like, no, I get stuck, so I like having time. But if you get stuck tomorrow, You stay stuck. You move on to another one, and then you come back to the ones you're stuck on. Yeah, we know. We're good. No. There's not. I mean, Lorenzo, was there a need anyway? No. Like this whole chapter. The only reason to use a calculator, I think, as far as practical use, would be if you're stuck on something, you just start plugging into a table and see if it converges, which would be cheating the system. So, anyway, we'll say no.